Stoichiometry. Stoichiometry deals with the quantitative relationships between the reactants and products in a balanced chemical equation. In other words, it allows us to do calculations on quantities based on what is presented in a balanced chemical equation. When we look at this balanced chemical equation here, we can see the coefficients have been put in front in order to balance this. So on this side of the arrow, we have 2 nitrogen. On this side of the arrow, we have 2 nitrogen. On this side, we have 2 times 3 gives us 6 iodine. And on this side, we have 2 times 3 gives us 6 iodine. So this is a balanced chemical equation. What these coefficients mean is that 1 mole of N2 reacts with 3 moles of I2 to produce 2 moles of Ni3. So the mole ratios come directly from the coefficients in the balanced equation. Mole ratios are also like conversion factors. So if I say I have 2 moles of N2, and we know that 1 mole of N2 can produce 2 moles of Ni2, we can then use that as a conversion factor to figure out how many moles of Ni2 we could produce. So which of these statements is not true about the reaction? Okay, so 1 gram of nitrogen is needed for every 3 grams of iodine. That's not true. As you recall, a mole is a set quantity of atoms within the substance, or a set quantity. Just like a dozen means 12, a mole means 6.022 times 10 to the 23rd. But each mole of every single substance has a different mass, and that's because each element on the periodic table has a different mass. So we can't say grams to grams just by looking at the equation, but we can say moles to moles. So calculate the number of moles of Ni3 that can be made from 5.5 moles of N2 in the reaction 1N2 plus 3I2 yields 2 Ni3. So what I do is put the information underneath the equation because it makes it easier for me to keep track of. Now they already wrote out the plan for you, but again, I like to keep track of it next to the equation. So calculate the number of moles of Ni3. So we go question mark, moles, Ni3. That can be made from 5.5 moles of N2. So we always start with the number they give us, and we're going to our question mark. So if we have 5.5 moles of N2, we're going to set this up like a conversion problem. So moles of N2 is on the top. We're going to put moles of N2 on the bottom. And we're converting 2 moles of Ni3. So now the conversions we fill in here come from the coefficients in the equation. So what is in front of N2? The number 1. What is in front of Ni3? The number 2. When we calculate by multiplying across the top and dividing away the bottom, our moles of N2 cancel out, and we're left with moles of Ni3. So 5.5 times 2 moles of Ni3 gives us 11 moles Ni3. So what does that mean? If we have 5.5 moles of N2, we should be able to produce 11 moles of Ni3. that's our final answer. Calculate the number of moles of I2 needed to react with 5.5 moles of N2 in that reaction. So I'm going to give you a minute to try to figure this one out, and then once you're done pausing the video and working through the problem, we'll come back and do it together. Okay, so we, just like last time, we're going to write the information underneath the equation. We have 5.5 moles of N2. And they're saying calculate the number of moles of I2. So our question mark is moles of I2. So we're going from here to here. And we're going to set this up like a unit conversion. 5.5 moles N2. Moles of N2 is on the top, so moles of N2 goes on the bottom. And we're converting to moles of I2. Now our unit conversion comes from the coefficients found in the balanced chemical equation. So we have a number 1 in front of the N2 and a number 3 in front of the I2. When we multiply across the top and divide away the bottom, we're canceling those, which leaves us with the moles of I2. So now we do 5.5 times 3, and that gives us 16.5 moles of I2. And that's our answer. So go ahead and work through this problem. Pause the video, and then we will unpause and go through it together. Okay, how many moles of HF, question mark, moles, HF, will be produced by the complete reaction of 1.42 moles of H2? 1.42 moles of H2. We're starting with the number they give us, going to the question mark. So 1.42 moles of H2. Since we have moles of H2 on the top, moles of H2 goes on the bottom, we're converting to moles of HF. Now we're going to use the coefficients from the balanced chemical equation. 1 is implied in front of the H2, and 2 is written in front of the HF. So here there's nothing written, but we are implying that there's 1 mole of that, and here is where the 2 is, in front of the HF. So we're going to multiply across the top, divide away the bottom. That cancels out these units, leaving us with moles of HF. So 1.42 times 2 gives us 2.84 moles of HF. Okay, so here is a list of steps for people that like listed out steps. You can read through these. The first thing you're going to do when you start with a stoichiometry problem is you have to convert the starting substance to moles. Then you're going to convert the moles of the starting substance to the moles of the desired substance. Then you're going to convert the moles of the desired substance to the unit specified in the problem. So far, we have started with moles and ended with moles. But there's problems where it'll start with grams and end with moles, start with moles, end in grams, or start with grams and end in grams. So we need to know how to solve those types of problems. So if you start with grams of A, in order to get to anything with B, you have to go from grams of A to moles of A, then you can get to moles of B to grams of B. So this mole to mole ratio is our integral step. So if I do this equation, for example, H2 plus F2 yields 2 HF, just like the last equation we saw. And if I asked the question that said, how many moles of HF can be produced if we start with 3.7 grams of F2? So we would go then from grams to moles. This is our substance A, and we're taking substance A to substance B. So grams of A is what we're starting with. And we can't just immediately go from grams of A to moles of B. We have to do this intermediary step, moles of A to moles of B. So this would actually lead to a two-step problem. First, we would go grams of A to moles of A, and then from moles of A, we could get to moles of B. So we'll do some examples of these as we go through here, but this chart is found in the chemistry aid sheet. You want to make sure to pay attention to this because this allows you to visually see the steps that are required. So how many moles of Al are needed to make 0.0935 moles of H2? So question mark moles of Al, and we want to produce 0.0935 moles of H2. So we're going from this to here. So we're going 0.0935 moles of H2. Since moles is on the top, we're going to put moles on the bottom. And then we're converting to moles of Al. Now we're going to use the coefficients that are found in the problem. So in front of H2, we have the number 3. In front of Al, we have the number 2. And we're going to multiply across the top and divide away the bottom. So 0.0935 times 2 equals, then we're going to divide it by 3. And we get 0.0623 moles of Al. Now why did we do that? Well, we're still going moles to moles. So we started with moles of A, we can go directly to moles of the second substance. So how many moles of HCl are needed to make 0.0935 moles of H2? Go ahead and pause the video and work through this one. Okay, so we have question mark moles of HCl, and we have 0.0935 moles of H2. So we're going to start with what we have, 0.0935 moles of H2. Since moles of H2 is on the top, we're going to put moles of H2 on the bottom. We're converting to moles of HCl. And now we have to put the coefficients in. So what's in front of the H2? 3. What's in front of the HCl? 6. So we're going to multiply across the top, divide away the bottom. 0.0935 times 6 equals, and then we're going to divide it by 3. We get 0.187 moles of HCl. All right, so you can pause the video and go ahead and work through this one. Okay, how many moles of H2, question mark, moles H2, are made by the reaction of 1.5 moles of HCl with excess aluminum? So we're saying in this reaction that we have tons and tons of aluminum, so we don't need to worry about how much aluminum is present because we have more than enough. We have only 1.5 moles of HCl, so how many moles of H2 could be produced in this reaction? So we're going in this direction. 1.5 moles of HCl. Moles of HCl is on the top, so we're putting moles of HCl on the bottom. We're converting to moles of H2, and now we have to fill in our coefficients. There's a number 3 in front of H2, and there's a number 6 in front of HCl. We're going to multiply across the top, divide away the bottom, and we get 0.75 moles of H2. How many moles of carbon dioxide are produced when 3 moles of oxygen react completely in the following equation? So go ahead and pause, work through this one. Okay, so how many moles of carbon dioxide, question mark, moles, CO2, are produced when 3 moles of oxygen, so we're starting with our 3 moles of O2. Moles of O2 goes on the bottom. We're converting to moles of CO2, and we're going to fill in our equations. There's a number 5 in front of the O2 and a number 3 in front of the CO2. We're going to multiply across the top, divide away the bottom, and we get 1.8 moles. Okay, so now this is a different kind of problem. We're starting with molecules of CO2. So if we go to this chart here, now we're starting with molecules of the first substance. So in the first step of the problem, we have to convert from molecules to moles. Then, once we have molecules to moles, we can convert from moles to moles. So go ahead and pause the video, try to work through this one, and then we'll go through it together. Okay. So how many moles of C3H8? So we have question mark moles C3H8 are consumed when 1.81 times 10 to the 23rd molecules of CO2 are produced. So we have 1.81 times 10 to the 23rd molecules of CO2. So our direction is this direction, and we are going to start with what they give us in the problem. 1.81 times 10 to the 23 molecules CO2. Since we have molecules of CO2 on the top, we're going to have molecules of CO2 on the bottom. And the first step we have to do is convert it to moles. Then, from moles of CO2, we can get to moles of the second substance. Substance B is C3H8. So, step 1, we're converting to moles of CO2. Step 2, we're converting to moles of C3H8. Now, what conversion factors do we put in here? Well, over here, we know that 1 mole is equal to 6.022 times 10 to the 23rd molecules. In other words, 1 mole is equal to Avogadro's number. It's not unlike if I put 1 dozen CO2 and 12 molecules of CO2. 1 dozen is 12. 1 mole is 6.022 times 10 to the 23rd. We do not use coefficients from the equation in this conversion factor because we're not converting between different substances. We're going from molecules of CO2 to moles of the very same substance. The only time we go and pull coefficients from the equation is when we are converting from substance A to substance B. That's what happens in this very next conversion. We're going from moles of CO2 to moles of C3H8. We have to use coefficients. So what number is in front of CO2? 3. What number is in front of C3H8? Well, there's no number, but we're imagining that there's a number 1 there. Otherwise, we wouldn't list it. So there has to be at least be 1. So what we do is we multiply across the top and then divide away the entire bottom. So doing this in the calculator is a little bit tricky, but we want to make sure that we multiply 6.022 times 10 to the 23rd times 3, and then we're going to take 1.81 times 10 to the 23 divided by whatever that answer was. Remember, anytime you use a number like this that's in scientific notation, we need to put parentheses around the number that's in scientific notation. One of the most common mistakes that I see that students make is they use coefficients for everything. But we have to remember, coefficients are only used when going from substance A, so the moles of substance A, to the moles of substance B. Every other unit conversion is our typical conversions that we would see. So when I put this in the calculator, I like to start by multiplying the bottom for this one. And remember putting that in parentheses times 3. And then I'm going to write that number down, which is 1.8066 times 10 to the 24. And then I'm going to take 1.81 times 10 to the 23 and divide it by that answer. I get 0.100. If you do not use parentheses, it's going to mess up your order of operations and give you the wrong answer. So remember, anytime that you're inputting a number in scientific notation into a calculator, you need to put parentheses around it. Okay, so now we're going to get into grams. So we talked a little bit about moles, then we went into molecules, and now we're going to talk about grams. So in this problem, what mass of H2, so question mark grams of H2, is made by the reaction of 3 moles of HCl? 3 moles HCl. So we're going from moles of HCl to grams of H2. So now we're going to calculate this. 3 moles of HCl because we have moles of HCl on the top, we're going to put that on the bottom. Looking at that flow chart, because we're starting with moles of substance A, we can go directly to moles of substance B. So we're going to go to moles of our new substance, substance H2. Then it wants us to go to grams of H2. So moles of H2 to grams of H2. Now we have to fill in our unit conversion factors. So looking at this, because we're switching between moles of different substances, we're going to use the coefficients that we have from the periodic or from the equation up here, the balanced chemical equation. So in front of HCl, we have the number 6. In front of H2, we have the number 3. Now here, we're converting between moles and grams of the same substance. So we're going to use our standard of 1 mole is equal to the calculated mass from the periodic table. Well, they already tell us the conversion up here. So this is their calculated mass from the periodic table. So we're just going to use that number, 2.02 grams of H2 and 1 mole of H2. Now we're going to multiply across the top and divide away the bottom. 3 times 3 times 2.02 equals, and then we're going to divide that answer by 6. Equals 3.03, and when we cancel out all of our units here, we end with grams of H2. How many moles of HCl are needed to completely consume 2 grams of aluminum? So go ahead and pause the video, try to work through this one, and then we'll go through it together. Okay, how many moles of HCl, question mark, are needed to completely consume 2 grams of aluminum? So we're going from grams of aluminum to moles of HCl. So we're going to start with the number that they give us, 2 grams of aluminum. Based on our flowchart, since we're starting with grams of substance A, first we have to get to moles of substance A because the only way to get to the other substance is through the mole-to-mole ratio. So since we have 2 grams of aluminum, we're going to put grams of aluminum on the bottom, and we have to get to moles of aluminum. Now the next step, we can finally get to moles of the new substance. So moles of aluminum, now we can get to moles of HCl. So in here, since we're going from grams to moles of the same substance, we're going to use our standard conversion factor. 1 mole is equal to the mass from the periodic table, which they have provided as 26.98 grams. Now here, our conversion factors come from the coefficients because we're going from moles of one substance to moles of another substance. So the number 2 is in front of Al, and the number 6 is in front of HCl. We're going to multiply across the top and divide away the entire bottom. So we can do 2 times 6 to give us 12, and divide that by 26.98 times 2, which is 53.96, because that's that times that. When we do 12 divided by that, we get 0.222 moles of HCl. We cross off our units here, and we're left with moles of HCl. Okay, here's another example. Go ahead and pause the video, try to work through this one. Okay, so what mass of AlNO3, 3, question, grams, AlNO3, 3, is needed to react with 0.93 moles of Na2CO3? So we're going from this to here. So we're starting with 0.093 moles of Na2CO3. Since we're starting with moles of that, we're going to put moles of that substance here. And in order to get to moles of the other substance, we can start right away with the mole to mole ratio. So we can go directly to moles of AlNO3, 3. And it wants us to get to grams of that. So we're going to go from moles of AlNO3, 3 to grams of AlNO3, 3. Now we're going to fill in our conversion. So since this is the mole to mole ratio, we're converting between moles of different substances, we can use the coefficients. So there's a number 2 in front of aluminum nitrate, and there's a number 3 in front of sodium carbonate. Now here we're converting between moles and grams of the same substance. So we're going to use our standard conversion factor of 1 mole is equal to the mass from the periodic table. They're providing that mass is 213 grams. If they did not provide that mass, you should know how to calculate that mass. So if you remember how to calculate the mass, there's 1 aluminum, and then there's 3 nitrogen, and then there's 9 oxygen, and then you would add up the masses of all of that. So they added that to 213 grams. We're going to multiply across the top and divide away the bottom. 0.093 times 2 times 3, and we're going to divide away that 3 that's on the bottom. That gives us 0.186 grams of aluminum nitrate. Ooh, did I screw that up? Hang on. 0.093 times 2 times 213. Sorry about that. Divided by 3. Okay. Sorry. So it's 213, not 3, like I just mentioned. The correct answer here is 13.2 grams of aluminum nitrate. Okay, so there's several other examples that you can work through. I'm going to go through these relatively quickly so that you have the answer. How many moles of aluminum are made by the reaction of 3.45 grams of Na2CO3 with excess aluminum nitrate? So we know that this is extra. This is not part of the problem. Sometimes seeing that in the word problem confuses students. The facts are, it wants to know how many moles of aluminum carbonate are made by the reaction of 3.45 grams of sodium carbonate. So that's the direction we're headed in. So we start with the number they give us. Grams of sodium carbonate, we're going to put grams of sodium carbonate on the bottom. We're converting to moles because we have to get to that mole to mole ratio. If we're going to go to a new substance, the intermediary is always going to be moles. Then from moles, we can get to moles of the new substance. So, grams to moles of the same substance, 1 mole is equal to calculated mass from the periodic table. Moles to moles of different substances, we're going to use our coefficients. There's a number 3 in front of sodium carbonate, and there's a number 2 in front of aluminum nitrate. So we're going to multiply across the top, divide away the bottom. So I'm going to do parentheses 3.45 times 2, close the parentheses, divided by parentheses 105.99 times 3, close the parentheses. And we end up with 0.0217 moles. You can go ahead and pause the video, work through this one. Okay, moles of oxygen, 38 grams of aluminum oxide. So we're going to start with the number that they give us, 38 grams Al2O3. We have to get to moles first, so grams of Al2O3 to moles. And then from moles, we can finally get to moles of the new substance. So 1 mole is equal to the calculated mass from the periodic table. So they're giving us the masses that are rounded. We need to actually calculate these. So there's 2 26.98 plus there's 3 16s. So that's 101.96 grams. And then we're going to do the moles coefficients from the balanced chemical equation. So there's a number 3 in front of the O2. There's a number 2 in front of the Al2O3. So we're going to multiply across the top, divide away the bottom. 38 times 3 divided by parentheses 101.96 times 2. We have 0.559 moles of oxygen. Okay, so now we're doing a mass to moles problem. Or sorry, mass to molecules. Molecules to mass. So I want you to pause the video, try to do this. This is going to be a 3-step problem, and then unpause and we'll go through it together. Okay, so what mass of HCl, question mark, grams HCl is produced when 1.81 times 10 to the 24 molecules of H2 So we're going from molecules of one substance to mass of another substance. So we're going to start with the number they give us. 1.81 times 10 to the 24 molecules of H2. Because we have molecules of H2 on the top, we're going to put molecules of H2 on the bottom. Now, in order to get to the new substance, we have to get to the mole-to-mole ratio. So we're going to have to get to moles of H2. Then from moles of H2, we can finally get to moles of HCl. But they want us to take this to grams of HCl. So that's our final step. Moles of HCl to grams of HCl. So now here we're going to fill in our conversion factors. We're converting between moles and molecules of the same substance. We're going to use our standard of 1 mole is equal to Avogadro's number, 6.022 times 10 to the 23rd molecules. Now here we're converting between different substances. So because we have our mole-to-mole ratio here, we're going to use the coefficients. There's a number 2 in front of HCl, and there's an imaginary number 1 in front of H2. Here we're converting between moles and grams of the same substance. 1 mole is equal to the calculated mass from the periodic table. So we have 1.01 times 35.45. And we get 35.8045. Oops, that's not correct. Sorry about that. I pressed multiplication instead of addition. So let's do this correct. 1.01 plus 35.45. And we get 36.46. That looks much better. Okay, so now what we're going to do is multiply the entire top and divide that by the entire bottom. We can ignore the number 1. So we're going to do parentheses 1.81 times 10 to the 24th, close the parentheses, times 2 times 36.46 equals. And we're going to divide that answer by the bottom. Now remember, we can ignore the number 1s, so we're going to divide it by parentheses 6.022 times 10 to the 23rd, close the parentheses, and we're going to get our answer, 219 grams. So putting it all together, what we just did, we started with molecules of the first substance to moles of the first substance. Then we did our mole-to-mole ratio because we wanted to get to the new substance. Then from the new substance, it asked for grams, so we ended up going in the third step to grams. Okay, so we're going to do a couple practice problems, and then we will go through the rest pretty quickly. So what mass of Br2 is needed to completely consume 7 grams of aluminum? So we're starting with 7 grams of aluminum. From grams of aluminum, we have to get to moles, because in order to get to the new substance, we have to do that mole-to-mole ratio. moles of aluminum to grams of aluminum, or sorry, moles of the new substance, Br2, and then from moles of Br2 to grams of Br2. Our conversion factors, since it's the same substance, 1 mole is equal to the calculated mass from the periodic table. Our mole-to-mole ratio uses coefficients. There's a number 3 in front of Br2, and there's a number 2 in front of aluminum. And then here we have the same substance. 1 mole is equal to the calculated mass from the periodic table. I'm just making all sorts of mistakes today. So, sorry about that. The Br2 is the 159.8 grams. And the aluminum is the 26.98 grams. Okay, now everything's in the right place. So we're going to multiply across the top and divide away that bottom. Parentheses, 7 times 3 times 159.8, close the parentheses, divided by parentheses 26.98 times 2. And we end up with 62. We'll round it to 2 grams of Br2. So what I would like you to do is work through, pause the video, work through the next few problems here, and then we'll unpause and we'll go through them together. What mass of Fe2S3 can be made from the reaction of 9.34 grams of FeCl3 with excess Na2S? This is excess, so this is not something that we're trying to calculate in the problem. So reading the problem, what mass of Fe2S3, question mark grams, Fe2S3, can be made from the reaction of 9.34 grams of FeCl3. So we're starting with 9.34 grams of FeCl3. And because we have grams of FeCl3 on the top, we're going to have grams of FeCl3 on the bottom. Now, in order to get to the new substance, we have to get to the mole. So we're going to go mole of FeCl3, and then we can go moles of FeCl3 to moles of the new substance, mole Fe2S3. From moles of Fe2S3, we can get to grams of Fe2S3, and that's where the problem wanted us to end. So now we're going to fill in our conversion factors. Since this is the same substance, 1 mole is equal to the calculated mass from the periodic table. They give this to us as 162.20 grams in 1 mole. Since we're converting between different substances, we're going to use the coefficients. So there's an imaginary number 1 here, so Fe2S3 is 1, and then there's a number 2 in front of FeCl3. Then over here, since this is the same substance, 1 mole is equal to the calculated mass from the periodic table. They give this to us as 207.91 grams. So to solve this, we're going to multiply everything on the top and divide by everything on the bottom. So I'm going to do parentheses 9.34 times we're going to ignore the ones. 207.91, close the parentheses, divided by parentheses 162.2 times 2, close the parentheses, equals. So I get 5.986064735. So looking at sig figs here, we're going to report the answer in 3 sig figs. Well, actually, we're going to have to round this up to 6.00 grams. What mass of oxygen is consumed when 54 grams of water is produced? Question mark grams, 54 grams. So we're going from 54 grams of water to grams of oxygen. Grams of H2O to moles of H2O. Moles of H2O. We can convert that to the new substance now, moles of O2. So that's our mole to mole ratio. And then they want the mass of oxygen, moles of O2 to grams of O2. So 1 mole is equal to the calculated mass from the periodic table. So we have 2 hydrogens, 2 times 1.01, plus we have 1 oxygen at 16, and we get 18.02 grams. Here is our mole to mole ratio. We are going to use the coefficients. There's an imaginary number 1 in front of O2, and there's a 2 in front of H2O. Now over here, we're going to use 1 mole is equal to the mass from the periodic table. So 32 grams is 16 times 2. Now we're going to multiply across the top and divide away the bottom. $47.9. And this one, what mass of water is produced, so question mark, grams, when 12 grams of HCl, going in that direction, so we're starting with 12 grams HCl, grams of HCl to moles of HCl. Now we can do our moles of one substance, HCl, to moles of our new substance, H2O. And they want the mass of H2O, so we have to go moles of H2O to grams of H2O. Remember, anything we put on the top has to go on the bottom. What we're converting to goes on the top. So I like to fill in all my units in a zigzag pattern first, and then I fill in the conversion factors. Since this is the same substance, 1 mole is equal to the calculated mass from the periodic table. 1.01 plus 35.45 gives us 36.46 grams. Here is our mole to mole ratio. We're converting between moles of hydrochloric acid to moles of water. We're going to use coefficients. So we have a 6 and we have a 3. Here, 1 mole is equal to the calculated mass from the periodic table. 1.01 times 2 plus 16. We get 18.02. So we're going to multiply across the top and divide away the bottom. $2.97.